Welcome to Prima Power's From Model to Finished Assembly. In this video, we're going to process a 3D assembly model of a toolbox. We'll utilize several pieces of Prima Power manufacturing equipment, as well as their respective software packages, to replicate what a typical process might look like in your manufacturing environment. First, we'll process the 3D assembly model through NC Express. Then we can show the same process through Tulus Office Premium, which is an optional, more advanced software package we offer. Then we'll move on and cut the parts on our Laser Genius 1530 with Combo Tower Laser. Then moving on to bending, we'll program the parts in Master BendCam for our BCe Smart 2220. We'll then bend the parts on our BCe Smart. We'll program the additional part in AutoPOL for our EP0520 press brake. Then we'll bend the parts on the EP0520 press brake, and then we'll show final assembly. In NC Express, first let's open up the 3D assembly model of the toolbox we're going to make. This assembly model includes all the sheet metal parts as well as all the hardware that's included in the original modeling. Historically, this could be a pain to have to filter out the sheet metal parts we want to make from all the additional hardware and such that are in the 3D assembly file. Luckily, NC Express has a built-in feature that can make this process much more automated, using some custom metadata properties that can easily be set in your solid modeling software. Here's an example of one way this feature can be used back in SolidWorks. We open up a piece of the hardware, in this case an M5 fastener, and go to Properties and Custom Properties. Here under the Custom tab of Summary Information, we can set a property name of sheet metal with a type being yes or no, and in this case being no, as it's not a sheet metal part we want to process on the laser. Now when we enter the Power Processing module, you can see that NC Express has filtered out all the hardware and left us with just the sheet metal parts we actually want to cut. By selecting the parts and clicking Process, NCX will save an individual part file, auto-tool that individual part file, as well as create a production order. Here we're going to select quantity of 3 complete assemblies to make. Now that the parts have been tooled and added to our parts order database, the next step of the process is to create the nests. As this toolbox assembly has 2 different thicknesses of parts to be processed, NCX will create nests for both the 30 thou parts and the 48 thou parts. We'll use the default nesting parameters for both. Here we can see the 3 different nests we're going to run to complete this order. The last step is to process the sheets, where NCX will optimize the toolpaths for each of the nests, and then allow us to accept the files and save the NC programs so we can send them out to the machine. Here, let's take a quick look at Tulus Office Premium with the programming and ERP connection modules. Tulus Office Premium is a very powerful tool for work planning, controlling the machine capacity, production reporting, as well as the ability to not only auto-tool, but nest production orders spit out from your ERP system. Here we're going to use an ERP simulator to simulate the release of a production order from your ERP system. Here we'll place an order for 3 complete toolboxes. Once the order is released, Tulus Office will scan a predetermined directory and then automatically populate the production orders in Tulus Office with the newly released order from your ERP. Next, we'll select all the parts and release them to production. Once released, we can go into the programming module and see that Tulus Office has pulled all the required information from the ERP order, from the model and where it's located on the server, to the name, the material type and thickness, the due date, as well as the machine these parts were specified to run on. Now we'll select all the parts and auto-tool and nest them based on the quantities required for this order. As the Power Processing module in Tulus Office uses NC Express in the background for the programming and nesting of the parts, You can see a warning here that's flagging that one of our nests is underutilizing the parameter in which we set up for this material type. We could add filler parts directly from this window, but in this case, we'll just include the nest to complete this order. Once accepted, Tulus Office will finish optimizing the programs as well as save them out so they're ready to be run on the machine. Once complete, we can schedule the job to the calendar or even add them directly to the machine if it's a rush order that we want to run immediately. We can go over to calendar view to actually see what's scheduled to run on each of the machines that we have available. Here we can see the two nests that we just created and when they're scheduled for production. They can be moved to a different time or a different day and even be opened up to see the details within the job. We're going to run these parts on our Laser Genius 10 kilowatt, attached to a combo tower laser with Tulus storage. First, we'll load the programs into the Tulus interface and get the job running. The Tulus Laser HMI is a numerical control system developed and manufactured by Prima Electro, a company part of the Prima industry group. It controls the X, Y, and Z axis of the machine, the focal axis, the laser generator, and the process gases. With a 19-inch touchscreen, teleservice remote connection, and complete integration with the laser generator, the Tulus Laser HMI is not only powerful, but also user-friendly. The Combo Tower Laser is a flexible storage system with integrated loading and unloading features for 2D lasers. Combo Tower Laser is a key module to automate material flow. It makes different materials available whenever needed automatically without delays. It can also serve as an intermediate storage for ready-cut components along with the skeleton. The Combo Tower Laser also provides an optimal solution for lights-out production, as capacity of available raw materials and unloading positions for skeletons can meet production requirements. The Laser Genius Evo is, in fact, an evolution of the fully tested Platino platform, marrying its reliability and flexibility with efficient state-of-the-art laser technology, with the addition of linear drives and laser sources up to 10 kilowatts. We've developed the Laser Genius Evo to provide customers with a production tool that is productive, flexible, modular, and user-friendly. The Laser Genius Evo cuts efficiently varied materials and thicknesses up to 25 millimeters from mild steel, producing quality results. Productivity increases are noticeable on the full range of thicknesses from the thin to thick sheet metal. Laser Genius Evo features a maximum trajectory acceleration of 2.4 g and a maximum trajectory speed of 240 meters per minute, and is available in 1530 formats as well as 2040. Prima Power is one of the very few companies who can proudly say, we make everything in-house. We don't buy parts, assemble, and try to make them work together. We decide what is the best possible production flow, then we build the components and develop features to reach those goals. Starting from our programming software, NC Express, and our Tulus laser interface. We also design our own cutting head and capacitive sensor. The Stonecast basement is our very unique feature, which allows a faster installation with no special foundation, vibration dampness, and ultimately makes us the only company to offer a cantilever design with the great advantage of a fully open concept. The all-in-one concept allowed Prima Power to develop some unique technological features to enhance the machine performances. The Smart Cut feature, for instance, focuses on every material up to 7 gauge and drastically reduces cycle times through intelligent management of head movement, such as on the fly piercing, no pre-hole, swift movement from one profile to another, and grid cutting. Night Cut increases machine uptime during unattended operations, exploiting a number of automatic devices, process control, and monitoring functions. Night Cut can be used for materials of any type or thickness and is particularly useful when intensive production demands make night shifts necessary, as there is no need for operator interventions on the machine. With Max Cut, piercing times are reduced by 90%. This is made possible through integration of a customized technology database with a package of technological options, the fruit of years of experience working in the field of laser applications. MaxCut is suitable for cutting thicknesses from 1/4 inch to 1 inch, using oxygen-assisted processes, and guarantees cycle time reduction up to 40%. Prima Power has developed its new fiber head with adaptive optics for the automatic management of the focal position, diameter, and a fast, reactive, and accurate standoff measurement. The new head is designed for excellent cutting quality and dynamics on all materials, the highest cutting pressures, certified mechanical structure, and the harshest environment with a totally sealed and protective case. The head is equipped with a single focusing lens, suitable for all production needs. Protective glass is integrated into the dedicated drawer for an easier inspection. Once the second nest is finished up, it'll be transferred out to the combo tower. Though the Laser Genius and the combo tower laser work seamlessly together, they are also independent machines, meaning anything that the combo tower laser needs to do, such as remove an I/O cassette, place a nest or part somewhere within the tower, the priority is given to making sure the laser has the next sheet to be cut to ensure maximum laser uptime. Tulus storage software for combo tower is a touch-operated user interface with a modern look and feel. The main display area is where different content of storage view and station view is shown. Cassette inventory view has advanced search functionalities to find easily wanted materials and parts. From the same view, it's also possible to order a cassette to the IOW station. Here we're going to call the cassette of the nest we just ran to the IO station to allow us to remove the parts and bring them over to bending. We're going to use Master BendCam to program the toolbox base. First, we can open up the PFP file and start the programming process, after selecting the base face and the orientation in which we want to start programming the part. We'll use one of the automated features Master BendCam has built in called short side cycles. Master BendCam will automatically program the short sides and then the long sides, as well as all the manipulations to complete the program. We now have a finished program, from the loading phase to the centering and pinning, all the manipulations and bends, as well as the unloading phase. We can play the simulation of the sequence and program that Master BendCam created. You can see the entire bending sequence on the right-hand side. The last step is to export or save the program so we can run it on the machine. During this phase, Master BendCam will double-check the program consistency, as well as double-check that there are no collisions between the part and the tools, or any parts of the machine itself. Let's start by loading the programs we're going to run on the BCe Smart. We're going to use the QR code barcode scanner on the BCe Smart to load the programs using the QR code that we etched on the parts on the laser. QR code and barcodes can be attributed to individual parts, or even better, in this case, we can save one QR code to a batch or a queue of parts to load all the parts with their respective quantities all in one shot. With the queue of parts loaded, we can hit cycle start and start running production. The operator loads the sheet metal blank and unloads the bent component in a single ergonomic sequence, while the machine automates the complete bending cycle to guarantee excellent bending quality. Prior to bending, the part does not need to be manually centered against the reference pins, but just pre-centered against an LED reference bar. A 3D programming system offers a complete simulation of the working cycle, thus making the first program run easy and reliably. With the addition of the barcode reader, running complex work queues or simply loading a single program can be done at the press of a button. Prima Power's bending cell, the BCe Smart 2220, is developed utilizing our experience with automation and bending technology since 1995, and is designed to solve a wide range of production requirements. The BCe Smart, with its compact solution, offers a new concept that revolutionizes the traditional press brake bending thanks to an intermediate level of automation. Our Servo-Electric technology was deployed for the very first time in 2004. It allows a non-hydraulic, fast, and precise bending solution, thus combining automation and superior bending precision, surface quality, and low operating and maintenance costs with a greater respect for the environment. The benefits obtained by Servo-Electric technology are 1. Lower bending cost by more than 60% savings in energy and 70% savings in maintenance costs. 2. Higher component quality. 3. Faster and smoother operation. 4. Shorter setup times. And 5. Capable of bending 100 thou mild steel at full length, 88.5 inches, and 118 mild steel at 74.5 inches. The BCe Smart has been designed for improved productivity. This is achieved by the unique loading and unloading operation that is done without any physical barriers. The operator can load a part on the brush work table without removing the previous bent component. Only when the part is on the table, the operator can take the finished part away and the machine starts the new cycle automatically. Warning lights with different colors are used to synchronize the loading and unloading stages. The additional information screen mounted in the loading-unloading area supports the operator by indicating the correct part orientation. The BCe Smart's main structure consists mainly of 2 frames. 1. The stationary main frame, and 2. The C-frame. The main frame is a solid welded structure that provides the necessary rigidity for withstanding the forces generated during the bending phases. The C-frame mounts within the main frame and supports the upper and lower bending blades for positive and negative bends. Active safety means a high safety level without losing productivity, but above all, a total safe condition for the machine operator. The newly engineered concept utilizes a CNC safety integrated system and laser scanners mounted in between the safety barrier. All stacking operations of the finished component and the loading of the next part to be bent can safely be performed while the machine is working, thanks to the scanner that monitors the presence of the operator within the loading-unloading area and protects them from risk by decreasing the working speed. The BCe Smart has a programmable crowning device as part of its standard equipment. Proportionally controlled hydraulic cylinders actuate the movement of the crowning device. The mechanism can flex the upper tool structure and consequently the tools. It's used to correct the straightness in thick materials or long bends. The BCe Smart. Fully servo-electric panel bender with inherently low energy consumption and extremely high precision. Higher productivity thanks to ergonomic loading operation in a single sequence with the unloading. Higher ergonomics thanks to 2 machine table layouts. Full operator safety without physical barriers thanks to the active safety. Best modern 2D, 3D cam for easy and reliable programming. Ease of use thanks to visual and acoustic warnings that avoid human mistakes. Easy loading of the part without manual centering against the reference pins. Reduced maintenance costs and energy savings. We're going to use AutoPOL to program the press brake. Let's drag the 3D model into the main screen and click the Unfold button. From here, we can use the wizard to go into the bending module and start to create our bending sequence. We're going to use the automatic bend sequencing that AutoPOL has built in. AutoPOL will select the best sequence based on minimum tool setups as well as minimum part manipulation throughout the sequence. Once the optimum sequence has been found, we'll use the automatic tool setup to allow AutoPOL to find the optimum segments for this bending sequence, based on the segments we've set up in the tool library within the software, as well as the segments we have out on the floor. Now that the program is complete, we can save all the files. Through the multi-save function, we can save not only the graphics and the NC directly out to the machine, but also the flat pattern and any documentation required as well, each going to their own individual place, either directly to the machine, on the local machine, or somewhere saved on your network servers. Let's start by loading the program onto the press brake control. Once loaded, we can check any particulars of the program, such as tool setup, or the laser safe parameters, such as utilizing box mode or tray mode. The on-screen graphics give the operator a 3D realistic representation of how to orientate the part throughout the bending process. Prima Power EP Series press brakes utilize a servo-electric drive system, achieving a fast, accurate, non-hydraulic bending solution. This concept combines productivity, accuracy, flexibility, and reliability with high respect to ecological aspects. It means greater versatility, lower power consumption, less maintenance, and no oil to purchase or get rid of. In addition, easy programming and outstanding accuracy eliminate wasted production. You simply make better sheet metal components at a lower cost. The belt and pulley system is actuated by Prima Electro servo drives and distributes the bending force over the whole bending length. The system consists of fixed and moving pulleys spread out over the total working length of the upper beam. The belt itself is a steel wire reinforced, maintenance-free belt. It's not a tooth belt, nor is it functioning based on friction, but the entire force is transmitted through tension, a simple and reliable solution. The Prima Power EP press is based on a rigid O-frame. The position of the upper beam in relationship to the lower beam is measured by dual Y1 and Y2 linear encoders that are attached independent of the machine frame and are bed referenced. The Iris block laser safety system by LaserSafe represents the most advanced safety solution for press brakes in terms of productivity and protection, allows for the operator to safely work close to tools without interrupting high-speed approach. Prima Power offers various sizes in our servo-electric press brake, from a 2-meter 55-ton machine all the way up to a 4-meter 200-ton machine. With hydraulic clamping, multiple back gauge options, as well as several angle measurement solutions, Prima Power can offer a solution to fit your needs.